Welcome back everyone. So in our first lecture in Mathematica series, we have understand the basics of Mathematica and some built-in functions, how we can use the built-in functions. And there were some set of rules. That means, let me remind you in a quick that whenever you are writing some function name or some symbol name, that should be start with the capital letter. If you are going to make some argument or input for that function, you need to square bracket. If the word is your function name is made of multiple words, then you need to make capital letter for each and every word, like find root, linear programming, like that one. And another set of rules was that you need to use comma to separate the items or values, and if you want to put in some range in some matrix, then you need to use curly bracket. So now here we are the second lecture for the Mathematica series, and this lecture is on plotting and graphics in Mathematica. I am Brij Mohan from the Department of Mathematics, Hansraj College. So I welcome again, and let's start it. So for doing plotting in Mathematica, we have many functions such as plot. P should be capital, normal plot, that means that plot will give you the 2D plot. Then plot 3D, if you want to plot in 3 dimension, then the function is plot 3D. If you want to plot in parametric form, then you need to use parametric plot. If you want to find your plot in your polar coordinates, then you can use the polar plot. Another plot is your contour plot. That means if you want to using the function f of x and y, that means 2 independent variables should be there, then you can use the contour plot. That means it will show you the projection or density on your 2D way. Another is list plot. So if you have list or some data and you want to use some data analysis on that and you want to see how the points are working and how the points are moving and what is the curvature for that particular set of points, then you can use list plot. So here are plotting examples. The very first and basic example is plotting the sin x function, and this is from x from minus 2 pi to 2 pi. Now you need to just understand how I am writing the input command. So here is plot function, is square bracket start, then sin function, sin of x, then curly bracket for range. As I have already said that you should need to use curly bracket for your range. So x minus 2 pi to 2 pi. Then just you need to go to the shift enter. You will get your value like this one. So that is very easy to see the plot for a particular function. So Mathematica provide you the graphical user interface in which you can see your plot in very easy way, and you can understand the functionality for that function. Another example is plotting 3D. So I have function x square plus y square, and you need to write x square plus y square as x cap 2 plus y cap 2, or you can directly use palettes to write. If you want to use palettes to writing like this one, whatever I have written here, then you can use palette x square plus y square. So the range for x is minus 2 to 2, the same set of rules, comma, then curly bracket x comma minus 2 comma 2, the same y minus 2 to 2, and you will get the 3D plot for that function. So that is your x square plus y square, and you will get your 3D like this one. Another example for parametric plot, if you want to plot the parametric, so you just need to write your functions here. So here you can see that this one is your curly bracket, that is our first parametric function, let's say f of t, then comma g of t, and you just need to put curly bracket there. So whenever you will write the parametric function inside the curly brackets, and you will give the plot range for your variable t 0 to 2 pi, and 2 pi you can see here. To writing 2 pi there are two ways. First way is you need to write 2 star capital Pi, that is the first way, and the second way is 2 space pi. So in Mathematica, to making multiplication between two symbols, you just need to make space. So if you are using space, that is correct. If you are using star, that is also correct. But if you are writing directly 2 pi without any space, that will be the wrong. So remember that, that's a very important point. So because here I am using here space, 2 space pi, and that's why it is looking at it, if you are looking at this is looking like you are writing 2 pi, but we have space in between 2 and capital P. So remember that. So to avoid this error, if you get some error, you just need to write always 2 star pi. So whenever you will be able to writing star between the variables or symbols, and your output will always be right. So sin t and cos t, and here you can see that you will get a circle, because sin square t plus cos square t is equal to 1, that is equation of circle. So you will get that plotting value as in your plot. Another function is, here you can see the polar plot. So if you are using some let's say sin 3 theta and theta from let's say 0 to 2 pi, so I am using a variable or symbol here u for theta. You can, if you want to write theta the same as given in your notebook, sin theta, if you want to plot the sin theta, then you need to pick theta from the palettes from basic math assistant. There are all the Greek letters, and you can pick from there directly theta, then you can put here theta. But if you want to use variable name just as anything, so you can put sin 3u and u from 0 to 2 pi, and the same work will happen. So your output will be in polar, and the polar plot command need to use for that. So and then you will get the very beautiful picture for your sin 3u. Another is plotting example. Here we have contour plot. So we have function cos x plus cos y. So this is the function cos x plus cos y, and the range for that x and y are 0 to 4 pi and 0 to 4 pi, and you can see this is your contour plot. Contour plot is basically the projection. So if you will plot first this one in plot 3D, to understand contour plot, first use plot 3D for the same command and see the structure, and after that plot contour plot, you will see that all these are nothing but the projection in your 2D space. So from 3D in your xy plane you will see the projection, and the projections you see the layer, that is the, so I can understand this will be look like this one, because this point is very near, so that may dark, then far away, that's why the lighter color is going outside. So that is basically the contour plot. You can understand the contour plot as a projection for 3D. Another example, list plot is also there. Okay, so if you want to plot some list is basically, that means you have different points in your list, 1 2 3 4 5 6 7 8 9 10, and you want to put it in your plot to see where are the points are moving, then you can just list plot and your list whatever you are using in your list by using curly bracket, as I already said, one dimensional list. Then you can see your points are there and they are moving in this direction. So you can analyze your points. Another plotting examples are there, and here you can see you can plot multiple functions in one graphic output. That means if you want to plot different function in one plot only, that you can do also. So for doing that, you just use the curly bracket and put all functions with commas, the same set of rules. So curly brackets, function, comma function, comma function, comma function. How many functions you are taking, you just need to put all these functions in curly brackets. So plot sin x cos x x square, and then you need to give the range. All functions will occur here. So that is for x square, like this one. That blue is for sin x, and this red is for cos x. So here we can see these functions. Other options will occur, that someone may ask that how we will see that which color represents which function. Then that is called as plot legends. We will come to that option soon. So as I have said, the options you need to use to make your plot very dynamical. So you can use plotting options, and the first is plot style. So specific styles in which objects are to be drawn. You can create plot style. You can fill also. So as your sin x is going like this one and you want to fill the axis, you can use the filling. Plot legends, as I have already said, if you want to see which color represents which function, then you need to use plot legends. Then plot range, from which range you want to do your plotting. Axis label, you can represent your axis label, axis name. For example, this axis represents temperature, this represents some density, like this one. You can do that also. So you can use plotting options to make plotting very clear to any reader who is going to read your plot, or going through your work, your research work, or any other. Many other options are also there. You can go to the plot options, and you will get different plot options there. Okay, come to the examples for the plot style. The very first plot style is here. You can see the writing way. You need to first write the functions, then range, then comma, then your options. Option is plot style. And the first plot style is what color you are using for the function. I have 3 functions here, 3 functions. So I am using 3 colors, red, green, and blue. So that is my style, that I want to make my plotting style in some colors for some particular functions. So sin x will be in red here, sin 2x will be in green, okay, this function, and then sin 3x will be in blue. So this function is this one. So I can easily understand which color I am using to represent which particular function. Another plotting option is filling. So we have sin x function, sin 2x function. Let's say I am using 2 functions, and the range is 0 to 2 pi. I am using the plot style same as green and blue. 2 colors are there because 2 functions are there, green and blue. This is blue and this is green. And another option is here, and you can use comma, then you can write your option filling axis, then your axis will be filled. So you can see x axis is this one. Whatever region you are obtaining in your axis intersecting with the axis, then all the space basically is filled with your color. So that is how we do the filling. Another plotting option is there, plot legends. In plot legends, now you can see, as I have said, that you can make very easy to understand to any user or any reader that which function or which color is this. So here this is came up by using the option plot legend. So plot legend function options is there, then you need to just comma, then plot legends, P capital, L capital, and you just need to minus, that is called arrow. In palettes you can use, and if you want to arrow by yourself, then minus sign, then greater than sign, that will come to arrow. In everything you are using arrow, remember that also. Then you can use the command expressions, and this expression is in your double quotes. So you will use the plot legends in expressions, and you will get this value here with your plotting, that sin x is green and sin 2x function is in blue. So other plotting option is plot range. That plot range is basically this one here, that is called a plot range. So what range you want to plot, that will show you here plotting. So same rule will be applied, comma, plot range P capital, R capital and arrow 2. So there is two way to giving your range. The one way is, if your point is from minus a to a, then you can directly give the value a, like this one 2. So that means your plot range is from minus 2 to 2. But if you want to plot range is minus 1 to 2, so both points are different, then you need to write in this manner, that is curly bracket minus 1 comma 2. So if points are different, then you need to put curly bracket first point and second point. But if your points are same but with a different direction, then you just put the point value as a. So that is from minus a to a. So remember that also. Then here is minus 2 to 2. So that is your plot range basically. So this is very easy to work, to create your plots in Mathematica, and you can easily understand that also. Another option is axis label. Okay, you can write your name for axis. For example, I want to write here that this axis is my x and this axis is my y, then the comma, then axis label A capital, L capital and arrow curly bracket, then x comma y, that is your name, x comma y. Whatever you will write here, that will occur on your axis label, like this one. You can use animation also. So we have gone through for plotting, for different type of plotting options, and you can use animation also if you want to see your functions, how they are moving with the different values, if there are some parameter involved. For example, here is one example I have taken to make it clear to you. For example, you want to plot sin x plus a, and this a is your parameter, and the parameter means that sin x plus 1, sin x plus 2, sin x plus 3, sin x plus 4, like this one. You can choose your parameter value and you can move that function how they are moving, then you can use that function animate. So animate function, what it does, it creates animation for expression which varies from minimum value to maximum value. So here I can see the plot command is already there. You can easily understand that from P to here, that is your plot command. So doing animation, you need to first use plotting command and then put that complete plotting command in your animation. So animate the plots for, then comma, your parametric range a 0 to 5, then animation running false. Why I have used the animation running false? By default it is true. So if this command is not there, that it will automatically run. It will automatically run. So you can see the moving of that curve. Whenever the value for a will be moved, this function also moved, like this one. So that is basically auto running is by default is true. If you want to put it on hold, then you need to give the animation running false. But here play button also is there. You can just click on play button and it will start auto running. So that is how animation works in plotting. Okay, now we have understand the plotting. Now come to the graphics, that you can use graphics in your Mathematica. For example, you want to draw some graphics around your plot, you want to add some text, you want to add something other things, add arrow, add circle, add 3D some graphics there, then you can use some graphics command there and you can easily work with that. So here is graphics command, graphics, and in this graphics you will use two types of inputs. First is primitives and the another is options. Options are like as you are using in plot. Option the same with comma, then options. So that is the same as you are using in plotting, but in graphics you will use primitives also, and some primitives are here. I have picked some important primitives. So many primitives are there. You can go to the help menu to check all the primitive list, but what are the basic and fundamental needed primitives you can see here. The first one is line. If you want to draw a line in your graphics, then you can use line, first point to second point to another point, and it will create a line. So you just put the points and it will create a line for that. You can use the arrow. Arrow function is there, arrow, and the same you just need to give points, then you will get arrow. We will understand all these function in coming examples, but here are syntax, so that's why I am explaining to you. If you want to use text, then text is there, put your expression there, and the position, xy is the position, at what position you want to put your text. Circle, if you want to put circle, then the center and the radius. So circle with center xy with radius r. You can put similarly disk and center with radius r, rectangle, minimum value, maximum value, maximum value, maximum value, like this one you can put the rectangle. So how you will create the rectangle, you just, for example, for rectangle there is no need to 4 points, there is need to only 2 points, the corner points here and the upper corner points here. So this is x minimum, y minimum, this is x maximum, y maximum, then automatically you can create rectangle. There is no need 4 points to create a rectangle. So that's why there is only 2 points to pointing the values for creating a rectangle in your graphics. And similarly polygon, if you want to draw some polygon for any work, then you can use the points and you can get easily. So options also there, and the options you can see that some options are same as your plot, and that is your plot range, the same. X is also there, grid lines is also there, or you can use the frame label, that is also there, and some background color for the plot you can use in graphics also. Frame is there, frame, that means your outer frame, wherever you are using your graphics, and you can use that frame, whether to put a frame around the plot. Similarly we will use a different type of options for our graphics. So let's start with the example for graphics. Here is one example for you. If you want to plot line, if you want to plot line, and the line points are, starting point is -1, -1 and 1, 1. So -1, -1 and 1, 1. So here is -1, -1, this is your -1, -1 point, and the 1, 1, this is your 1, 1 point, and you will plot this line like this one. So it's very easy to understand that how you can use graphics, and you can see that frame is also there. This is known as frame. Whatever you are seeing here, that is called as frame. So I have axis true, yes, axis is true, so that is basically axis here, from here to here, this is your axis, and this is your frame. Frame is true. So remember the commands, how we are using. Axis true, so axis will occur, frame true, so frame is also there, and you can see the command axis arrow, so you need to use that particular arrow as minus and greater than, and the plot range is 2. So you can easily understand why I am writing 2, that means -2 to 2. If you are picking the one particular number, that is -a to a. So that was the one example for line. Another, you can see the arrow. Now you can understand the same way, the same pattern we will follow to use graphics. So graphics, arrow, remember whatever I am using primitives and options, graphics command is always there. Graphics inside I am using primitives and options. So arrow, starting point and ending point, and you can see here from -1 to 1 1, and this arrow is also there. So if you want to plot arrow, that is very easy in Mathematica. Here is another arrow, but it has both side your head, arrowhead in both side. So the command is arrowheads minus 0.1 to 0.1, that is the size basically what you want to pick the size for your head, and that's why minus 0.1 this one this one, and the command arrow is this one. So you need to put arrow first, so it will show you the one head, but you need to use both and as your arrowhead, and that's why the command arrowheads is used here. So remember that also. Other things are same. Now I am adding one text here, double headed arrow, double headed arrow. So what I am doing, I will just put one text and some particular point. So here is the command text double headed arrow in double quotes, and the points where I want to put minus 0.5 to 0.5. So that is our 0 to -1. So 0.5 is this one and 0.5 is this one. So the middle, this is in the middle position, and in that positions that particular text will come, and you can see that at the exact position it's happening. Another is you can do the graphics example. For example, you want to draw the circle, that circle command is already there. So just put graphics, circle, center, radius, and other examples I have already added in this one. That means using comma and curly bracket. You can use multiple primitives at the same time, but just you need to add functions in your curly brackets. So it is circle and disk. So this is your circle and this is your disk. Another example, you want to draw the rectangles, then you need to just give the 2 points value and the lower points and the upper points, write this one. So rectangle -2 -1 to 1 and the plot range 3. So this is our plotting for rectangle. Since the range is bigger, -3 to 3, and that's why this is -3 to 3. And I have given background color as green. So the background is green and my rectangle is black. So my rectangle answer is black and the green is your background. Whatever range you are picking, this will be filled with the color what you have chosen. So here is another example. If you want to plot polygon, so here is graphics command, polygon, and the points. So in your polygon, I am giving the value first point -1, 0, second point 0 and 2, third point 1 and 2. So this is -1 0, this is your 0 2, this is your 1 0. It will automatically connect all the points and it will be filled by the default color, that is black, and the frame is true, plot range is 3, that means -3 to 3. Another example, if you want to pick the color as blue, not the black as by default, you just put the color name before that. So I have started polygon here like this one in the previous example, polygon, this was the command, and in the next one you can see I have just added the color name blue in the starting and put it all these in curly brackets. So that is how you will work in your putting the value blue for that. You can choose your own color, whatever you want. So similarly, you can go to the graphics in 3D also, as we have plotting in 2D, plotting in 3D. In the similar way, similar way in 3D also you can use your graphics. So here is graphics 3D, and you can use some examples as I have picked here. That is sphere. You can use a sphere, the center and radius, then cylinder. Here are some cylinder XYZ, that is your points for center points, XY ABC. So that is your cylinder starting and ending. That is center point in the below, center point of the above, and then you can write with the radius R. Then you can plot your center cylinder. Then cone is also there, XYZ ABC, then R similarly as cylinder. Then you can plot tube also. You can see all commands look like same, just little bit difference. So remember that. Here are an example. If you want to put graphics 3D sphere, and that is our center 0 0 0 in 3D, 0 0 0 will be in the middle somewhere in this sphere, and the radius is 1, that is your R, and that is your center 0 0 0 inside the sphere. So if it is the sphere, that is inside that center point is 0 0 0. So you will use the command graphics 3D, D should be capital, graphics 3D sphere square bracket, in curly bracket you will give the point, center point, then radius, and a square bracket close, and then you will get your output and 3D graphics. Another example, I have combined the two sphere, and you can see some 3D graph is there. So graphics is sphere, center, radius, sphere, center, and radius. I have a radius 1 for first sphere, so that is big one is 1, radius is 1. Another one is 1/2, that is half, and the position is 0 0 1, that was the 0 0 0, and that is 0 0 0 1. The center is at the boundary, So center for this one is somewhere here, and this is like this one. And when you will combine both graphics, it will look like this. Similarly, you can see the graphics 3D for your cylinder. As I have already said that you need two centers. First center is here, this one, and this one. Another center will be for this phase, right, inside somewhere. If it is like this one, so center will be here, like this one, and your radius, because you are making cylinders, that is radius should be same at in the below and the upper side. Another example, you can pick the cone, same, very easy. Whatever you are using the position, so that is the center 0 0 0, then 1 1 1, this one is the position, and what is the radius for that one you will put, and the cone will occur. Another graphics is tube. You can plot the tube also. The same command will be there, and you will get the tube with 0.2 radius size. So this was our second lecture in the Mathematica lecture series. So see you in the next lecture. Be connected. Thank you.